So that's recording. And then shift it.
All right, so if we're looking at this, the rule basically boils down to this summarization. I'm going to take the two pieces of one chord and multiply them, and they're going to be equal to the two pieces of another chord multiplied. So based on what that said, what I just said, what would go in the blanks here? If I say AE, what would go with AE?
B.
Either one, BE or EB. All right, so I'm going to take the two pieces of this one and multiply together, and then that's got to equal to the two pieces of the other one. So CE would have to be multiplied by
CD.
BD.
ED or DE. Now, am I saying that AB is the same as CD lengthwise? Absolutely not. It's never going to be equal. I'm not saying that AB is 8 and CD is going to be 8. What I am saying is if you multiply them together, they're going to be 8. So something like 2 times 4 right here would be the same as 8 times 1 there.
So it don't matter what's the length.
Mm-mm.
Okay.
Length is irrelevant. We're just saying the two pieces of one multiply and equal the two pieces of the other. All right, get that one. All right, all of this junk up here, it says product of the lengths of one secant segment and its external segment equals product of the lengths of the other secant segment and its external segment. First of all, what does external mean?
Outside.
Outside. So I know we'll be talking something about the outside piece. All right. Well, this says the product of the lengths of the secant segment. Well, that means the whole thing, and it's external. Well, product means what? What? What does product mean? Multiply. Thank you. Multiply. So we're going to multiply the whole thing times the outside piece. That's the rule. Whole thing times the outside piece. So what is the whole thing up here?
B.
BE. What is the outside piece?
Oh, okay.
EA. Everybody see that? Whole thing times the outside. That's your rule. If you remember that, it should be easy. Well, then the whole thing on the bottom one is DE,
Yeah, but
and then the outside piece is
C.
CE. That's it. Whole thing times the outside. Whole thing times the outside. You might want to write that down. Whole thing times the outside. You do that for both sides. They got to equal when you get done. All right, for this rule, it says the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent. First of all, we need to identify which one is the secant, which one is the tangent. So which one is which?
The tangent is AE.
Why? How do I know that?
Because
Because it outside, but it hits the circle one time. And then the secant is DE because it goes through and hits it twice. All right? So on this, it says the product of the lengths of the secant segment and its external. External means what? So I'm going to do the same thing I just did on this last rule. When it looks like this, the DE part, what does I say that rule was? What times what?
the whole thing times outside.
So I'm going to do the whole thing times the outside. So in this case, the whole thing is
DC.
E, and the whole thing is DE, and then the outside piece is. And then what do you do with the tangent? Is you square it. So that's where the EA squared comes from.
We squared it.
The A.
You square the tangent one. You take whatever that number is and square it. And then you're going to do the whole thing times the outside. All right, so we got 3 rules. Let's go back and look at them. This one, what am I doing on the first one?
You the what's the thing called? You just doing like C
I'm going to do the 2 pieces of one chord, multiply and equal 2 pieces of the other. Then I go to the second one here, and I would say whole thing times outside equals whole thing times outside. And then the last one here is whole thing times outside equals tangent squared. All right? See what you can do with those. All right, I'll work number 1, then y'all can have 2 and 3. Which rule is this? 1, 2, or 3?
The first one.
First one, which means I'm going to take the 2 pieces of each chord and multiply them together. So I'm going to take this one and say what?
Multiply.
So I get what?
So like you
Six.
multiply 5 and
6.
This one would be 5 times 12. Right? That's the 2 pieces of that one multiplied together. Equals,
Yeah, equals x times 6.
and I'm going to do 6 times x instead of x times 6. It'll work both ways. So there's my equation, and I solve my equation. So what do I get?
10.
What?
Wait.
No.
What is this? 5 times 12.
6.
60 equals 6x. Then I divide and get 10 from my answer.
That's what I.
All right. See if you can do the second one. We'll have to do the third one together. All right, let's look at number 2.
Ooh, cold.
Tell me the equation to set up for number 2.
9x equals 15 times 3.
All right. Are there any questions or problems with where that setup is coming from? So then I'm going to multiply my part over here and get 45. Divide by 9 and get
5.
x equals 5. Now, if I use that same process, what do I get over here?
6x squared.
Well, 3x
Yeah.
times 2x equals 4 times 24.
Oh no,
All right, is there any questions about why it's set up that way?
because it's
You're doing the same process. The 2 pieces of one multiply together equal the 2 pieces of the other. Now, here's where people forget. What do I get when I multiply 3x times 2x?
6x squared
6x squared. Do not forget the squared part because that's going to be important in just a minute.
equals
4 times 24 is 96.
Put 6 upon it.
So I'm going to divide by 6 next.
And can't you cancel it and do x root squared equals
Wait a minute.
96?
Not yet. I get x squared equals 16. I do the division part first, and then I come back and do the squared part. So how do I undo when something's squared? I do square root.
Yeah.
So what is the square root of 16?
8.
Oh, goodness gracious.
4, yeah, my bad.
We're not dividing by 2, we're taking the square root. All right, are there any questions about that page right there? That was the first rule. The 2 pieces of one chord multiply equal the 2 pieces of the other chord.
I went with the first rule.
All of these were the first rule, yep.
it's just basically a cross what they put down.
All right, copy those down and we'll go through them. All right, so here we got the second rule, which says outside times the whole thing. May need to say it, whole thing times outside. If I look at that top part, how much is the whole thing? 16. It's not 13. Everybody understand that part? You've got to add these 2 pieces to get the whole thing. So outside, or excuse me, whole thing is 16 times the outside piece of that thing, which is 3. So there's my whole thing times the outside there.
Wait.
Whole thing is 3 plus 13.
Oh, okay. Oh yeah.
And then outside is 3. Now here's the bottom part, kind of messes people up sometimes. What is the whole thing on the bottom piece?
4.
No. It's just x. When it tells you this right here and has that line drawn, it's telling you that's how far that part goes. Well, that's the whole thing. So x is the whole thing times the outside piece, which is 4.
Okay. 16.
3 plus 13.
3 plus 13.
Yep.
Okay.
You got to add those 2 pieces up to get the whole thing. Then you just have your regular equation and you solve it. Well, 16 times 3 is 48. 4x. Divide by 4.
12.
And you get 12. All right. Now, notice number 2 is a little bit different than number 1. Why is it different?
Because
It don't tell you that x is the whole side. But the rule is still the same. It's the whole thing times the outside. So if I'm looking at the top one, what is the whole thing for the top? 10. Times the outside piece. Does everybody see that? Whole thing is 10 when I add up the 6 and 4. The outside piece is the 6.
I get 10, I got 9.
6 plus 4.
4 plus 6.
Whole thing up here is 6 plus 4. Alright? Now, what is the whole thing for the bottom piece? Nope.
It's times
X
5.
no.
It's
X
times
plus
5.
5. X plus 5.
X plus 5. How do I find the whole thing? What do I do with the two pieces?
Oh,
Add them. I did 6 plus 4. I'm going to do the same thing here. The whole thing is 5 plus X. The outside piece is 5. So there's my equation I've got to work with. Alright, so I multiply the left side and get 60. What happens when I multiply this stuff on the right? What do I get?
25 8.
Nope.
20 plus.
I've got to do the 5 multiplied by both parts. So now I have my equation. 60 equals 25 plus 5x.
So now you got to do 25 subtract.
Minus 25 on both sides. I get 35 equals 5x. Divide by the 5. You get 7. Alright, see if you can do number 3 like that. Which one is it going to be like? 1 or 2?
2.
It's going to be like number 2. Alright, let's look at number 3. Tell me the equation that I have, the setup that's going to work.
14 times
14 times 6 equals
It's
5
equals
X.
Alright, I'm hoping somewhere in what y'all just said was this.
Yes.
14 times 6, because there's the whole thing times the outside.
X.
7 plus x is the whole thing times the outside 7.
So
Multiply that out. 84 equals 49 plus 7x. Remember, multiply both parts right there. Minus the 49.
35
Get 35 equals 7x. Divide by 7
Equals 5.
and get 5.
Boom!
Any questions about this rule? Alright. Copy those two down. Alright. Again, what does the rule say on this?
You still got to do
Whole thing times the outside and square the tangent. Well, the whole thing times the outside. So what is the whole thing for that bottom? 20 times the outside piece, which is 5, equals the tangent one squared. Now, if it's like this, these are the easy ones. If you have the x as your tangent, those are easy. Well, multiply it out. That's 100 equals x squared. If I have a squared, what do I do in the problem? Do the square root. So square root of 100, square root of x squared. Square root of 100 is 10. That becomes x. Got your answer. Alright, you should be able to do number 2 now.
It's still the same way, although one of them on
Tell me the equation for this part right here.
14 times 4 equals
The 14 is the whole thing, 4 is the outside. Whole thing times the outside, then square the tangent. This becomes 56 equals x squared. I'm going to square root that. Doing the decimal version, you get 7.5. All right, now, can anybody tell me how to break that down and leave the square root on there? What is the square number that goes into 56? Remember, square numbers are 4, 9, 16, 25, 36. 9 going to 56? 4. We just did it, y'all.
Oh yeah.
So this would be 4 times 14.
That's long.
And what's the square root of 4?
2.
And then square root of 14 doesn't change, so this is the same as that.
We have to do that.
You're going to have to on the EOCT. So,
We have to do it on the test.
not right now, but for EOCT purposes, we're going to have to do that. All right, are there any questions about anything we've done? All right, pick it up tomorrow.
We done?